Good afternoon to everyone at SEDS who's listening in. It's looks like you've had some good talks today. I haven't quite caught all of them, but this is really a neat thing you're doing. So I'm Dr. Jon Van Noord. I'm the Associate Director of Education, also the lead mechanical engineer of the Space Physics Research Lab here at University of Michigan. And I'm going to give you hopefully a quick overview of what we do at SPRL. Have to admit, I graduated a PhD from the College of Engineering back in '99, and before that point, I wasn't even sure that SPRL existed, and have come to learn, of course, working here, that we've done quite a few interesting and great things. So hopefully by the end of this talk, you'll have a good sense of what we have been up to in the past, but also what we're currently up to. Um, so other people, there's Professor Brian Gilchrist is the director, and Pat McNally is the managing director of our lab. Um, so our lab is located in the Space Research Building on North Campus across from the Aero Building. We're basically in the west wing, first floor, if you need to find us. We've been supporting University of Michigan principal investigators in development of space research instruments since 1946. So we've actually been around for quite a while. We've had over 100 rocket, aircraft, and balloon experiments developed to date, and over 35 major space instruments that we've helped develop. We currently have around 25 engineers and 10 technicians, so staff of about 35 people currently working. Our directives. So SPRL's mission is to use our expertise in engineering for harsh environments. So we typically deal with outer space, but I'll talk a little bit about some of the other things we do, other harsh environments, supporting the critical work at the University of Michigan. We engage in a lot of what we call elevating the technology of TRL, which probably a lot of people are familiar with that term. The technology readiness level ladder from concept to flight. So we're doing concept designs all the way to implementing them for flight and sending off flight instruments or small spacecraft. We also help educate the students in preparation for future decades of space exploration. So our primary job is really engineering, but we're also look to kind of leverage that engineering to help augment the education, which is happening at University of Michigan, which actually that's part of my role as Associate Director of Education at SPRL, is to try to help find those connections between our engineers and the education and the students out there. The main focus at SPRL, as I mentioned, was space systems, but we also have experience in like robotics, advanced automotive system, MEMS, NEMS, and sensor technology. There's a lot of overlap in a lot of those systems. So while we do primarily do space, we've branched into these other ones. And so on that note, you'll see that we're known as SPRL. We've been SPRL for years, but we also have kind of the brand name of Extreme Labs to kind of it's a lab within a lab, although the primary lab is SPRL, but the Extreme Labs kind of captures the work we do outside of the space endeavor. We will advise student teams who will serve on review panels at capstone courses and work side by side with labs and students. I recognize at least a handful of students there that I know I've worked with already that have either presented today or in the audience. So getting on to some of our history. So again, started in 1946. Originally, the work was around the V2 or probes that went on the V2 rocket. So after World War II, they captured a whole bunch of V2 rockets. I think it was somewhere between 40 and 60 rockets they captured. And they looked to basically re-instrument them for doing science. And so University of Michigan was involved in some of the early V2 science missions. The initial instrument was, you can see in the upper right, a double probe, which is used to measure atmospheric neutral temperatures and densities, along with a Langmuir probe to measure ion and electron temperature. There's a lot of excitement with that first flight, but like a lot of rocket launches, the first flight went up about 300 feet, I think it said, went horizontal, and about a mile later crashed. Thankfully, that was not the end of the missions, but started out with a little unintended excitement. So back in the 50s, SPRL was part of the electrical engineering department, and a lot of the work was kind of related to those original probes that they had developed. We quickly go on to the 60s. There were two labs that did kind of similar work, but the High Altitude Engineering Laboratory and SPRL. A lot of this work was managed by one of the two, and it accounted for at least half, nearly half of the external funded research in the College of Engineering. So in the 60s, SPRL and HALE were a big part of the work that was being done at the college. And again, a lot of that work were on Langmuir probes and these neutral mass spectrometers. In the 60s, the mission that they worked on was this OGO 6, um, for looking at, like in that case, you can see the picture on the right, studying the radiation in a polar orbit. So if we go into the 70s, quick job there. That's when SPRL joined up with the AOS, which is now CLASP, and they moved into the new NASA-funded Space Research Building. So that building you see there on North Campus was funded originally by NASA to do work for them. We quickly move into the 80s, and we did a lot of more optical remote sensing was kind of added to our type of missions we worked on. Probably the biggest mission that at the time we worked on was HARDY, the high resolution Doppler image, and you can see on the right the hardware there that they're working on in the 80s. We moved to the 90s. Actually, I initially started working with SPRL in the 90s and the 2000s, and we've done a lot more work on mass spectrometers. It launched in early 2000, but a lot of the work with us in the 90s was on the FIPS or messenger mass spectrometer, which you can see that in a lower picture, which the tough thing with that was the size. We crammed in a lot of high voltage work into this mass spectrometer, and the optics portion of it is about the size of a Coke can. So it's a pretty small instrument that we had to work with, and voltages, I think, on the order of like 12,000 kilovolts in that instrument. We move on to the tens. So this decade, Extreme Labs was formed, as I mentioned, but SPRL is still the primary lab within that Extreme Labs. We moved over to the college, so we are now actually a lab of the College of Engineering, so no longer part of CLASP. Although a lot of our work still often we work with CLASP for most of what we do. And Cygnus was our major project. There we go. I don't have to click the GIF. But Cygnus was our dominant project in the tens, and I think we've been, I think it's been 4 or 5 years now that it's been flying. I think 4 years flying in orbit successfully and still getting data. So that's a brief history. So we get into kind of somewhat like the breadth of work that we've worked on in SPRL to give you an idea that we've actually worked on a lot of hardware that's gone to a number of different planets, anywhere from solar. So HISS is a spectrometer, which I think just recently launched on the Solar Orbiter. That's flying for measuring, basically solar wind and stuff coming from the sun. Messenger, the FIPS instrument I mentioned, is I think it crash landed. I think they crashed on the Mercury at this point. That mission is done, but quite successful. I think they detected things like water and stuff like that with the instrument. Currently working on a Mars 2020, which is up at the top. We're responsible for the uh, I think it's a 30 kilovolt power supply for the X-ray source on the rover. The Mars 2020 rover is ours. Around Earth, we've had a number of missions. We haven't done too many CubeSats, but QB50 was one where we stepped in to help Aaron Ridley with some CubeSats, and in about 3 month turnaround, we from bottom up designed the and executed the CubeSats, the QB50s, which again those were successful. I think the science instrument had some problems, but the CubeSat itself worked well. You have Cygnus, which is again Earth observing. You look in the upper right, and that's the PIMS. It's a Faraday cup that we're working with, and that's for Europa mission. So we've actually had a lot of exposure to multiple environments, not just Earth, but you can see the various kind of solar system objects that we've worked with. I'm not gonna. This is a bit of an eye chart. I'm not going to hit all of these, but you should get at least a feel for a lot of the projects that we kind of currently have been working with. Cygnus, I mentioned. So his PIMS, Mars 2020. A couple that are not on here, which are not flight projects, which might be of interest. We're currently doing one development project called RADWorks, Radiation Works, which is looking at using electrostatic fields to shield astronauts. So I know, especially if there's, thinking of the human component, we're working with, I think, JPL and not Marshall, down in Houston. You know who they are. I just slipped my mind. But we work with a number of the agencies, but RadWorks is one of the more interesting ones that we're testing. Another one, we're working on a CubeSat right now, which is like a 50 kilovolt CubeSat. Probably a lot of the work we do that's really special is high voltage power supplies. So dealing with not just the mass spectrometer, but dealing with power supplies that can get to voltages that are definitely pushing the limit of what's been done in space. Um, so our those are a couple of our current missions. To give you an idea of our current operations, besides those things, like I said, we have about 35 staff members. I don't have the current stats for like FY, 19 or 20, but FY 18 is pretty representative of type of stuff, kind of breadth of stuff that we've worked on. We had about 40 projects then that we were working on during that financial year, probably similar to right now. We worked with 23 different principal investigators. So a lot of times we're supporting the principal investigators. Some might be in SPRL, but a lot of them are in the various departments or other organizations that we're working with. We have supported in 2018 like 8 different departments at University of Michigan. Worked with 8 different federal agencies, so not just NASA. Um, there's a whole breadth. I think Department of Energy is another one. We have one industry sponsor in that year, and worked with 4 research or academic centers. So we've worked with a lot of different organizations. Typically, not just one, but we have a lot of relationships out there with the in the space industry. So to give you an idea of kind of the scope of type of projects we work on, if we start on the left, we work on essentially a wide range of like cost type projects. Anywhere from the top is like think a little 30,000 precision part for like a chemistry mass spectrometer, all the way down to the CubeSats to Cygnus, which was a $100 million project, which was managed out of SPRL. Um, as I mentioned, we work with a number of environments, not just space flight, but we uh, also work with, we've worked with stuff like Europa, or if we have the Antarctic is the middle picture, there's a magnetometer or electric field centers in a dry lake bed. We also are very much with development, either from quick development stuff like torque rods we had to build for the Cygnus spacecraft, which we fell into because the company that was making them went bankrupt. And essentially, SPRL had to jump in and make these, and we did these in also about I think, on a 3-month kind of time frame. Then Mars 2020 is sort of a lot more sophisticated, obviously dealing with Mars, dealing with all the protocols you need for stuff for Mars type projects. The major technology experience we have at SPRL, we're really electrical heavy. So we do a lot of the embedded processors, programmable circuits, ASICs, custom magnetics, power supplies. As I mentioned, we do up to 100 kilovolt supplies. What we're working on right now, those are low current, high voltage, so electrostatic supplies typically. Myself, we've got a couple mechanical engineers, so do a number of the typical mechanical type stuff in support of projects. We deal with these kinds of sensors: visible, ion electric, RF, magnetometers, inertial sensors, mass spectrometers are the typical sensor design that we work with. And we have some software people too, supporting the mission, ground and data analysis and image acquisition type things. Um, Another key thing about us is our facilities. So as I mentioned, first floor CSRB. We have about, I think, 12,000 square feet of space we work in. We've got a clean room. You can see in the lower right picture, there's a Space Flight Operations Center we've got located in CLASP, that we've got high capacity servers, it's multi-mission capable, fabrication clean room available, and we have ITAR controlled areas, so limited access areas for dealing with ITAR type projects. Other facilities we've got a number of, one big thermal vac chamber, but a number of thermal chambers. We've got a couple of vibe tables. You can see Cygnus on a vibe table, Cygnus in one of the thermal vac chambers. We've got a machine shop. You can see Chuck, our machinist, working on the lathe that we have there. And if I can catch my breath, now the summary. So SPRL, as I mentioned, we have a really rich history of dealing spaceflight hardware for quite a long time. Our hardware can be found across the solar system, and we've got a lot of experienced personnel and facilities that can support a lot of endeavors, especially space flight work. So with that, I think I crammed in a lot of information into 15 minutes. I think we're, Sahil, I think we're open to questions if you manage that.
Yeah, for sure. Thank you so much for that talk. I like how at the beginning you mentioned, back when you were still a student at the University of Michigan, you had no idea what SPRL was, because that was like part of the whole problem that we were trying to solve with Space Symposium Day. Like I personally didn't know what SPRL was, and then when you sent me the slides, I just went through it and I'm like, wow, this is
Yep.
absolutely amazing.
Yeah, no, I feel a bit like, I don't know if you people know who Rodney Dangerfield is. He's a guy who says, I get no respect. It's almost like at times where we don't do a very good job, I'll say Spurl, of letting people know what we're doing. And there's some really cool things when people learn about it, especially what we're capable of and have done. It's like, I didn't know we did that here. It's amazing. So I'm glad that that was your reaction, because it's some cool stuff. And if when things get a little that we can get people in there, we're happy to give tours too. So if there's ever a follow-up that are groups that want to have a look and see what, just see the space, they're welcome to come over.
For sure, that'd be amazing. All right. If there are any questions, again, you can raise your hand and I can unmute you to ask the question, or you can send them in through the chat and I can relay them on to Dr. Van Noord.
Looks like I overwhelmed them.
Do you have an idea of what future projects SPRL might be working on?
That's constantly in flux. So I mean, like I mentioned, the current ones that we're actively in are like the RadWorks. The mass spectrometer I mentioned is one where we are, we're in the process of, the early stages of developing that instrument. Trying to think of other, we work a lot with, like, especially with Goddard. So we're frequently kind of, we support a lot of the heliophysics group. So it's pretty common that we're doing missions related to heliophysics. So while we can do a lot more with that, that's kind of almost been our bread and butter. But right now I know they're actually supporting a company up in the UP with Hall thrusters, building like the power supplies for Hall thrusters. But that's like I'll say a commercial endeavor. Our main thing is working with the university, but with our expertise, we offer it kind of especially to Michigan and other groups to kind of come in and also, like the Vibe table and thermal vac. I know we have a new company in Ann Arbor that just came here who is doing, I think, radar system, like CubeSat radar systems, and they saw our thermal vac and Vibe, and they're like, oh my goodness, this is great. So we don't have to go to like go to Lockheed to do this. We can come right here. So our future work is mission, but also doing supporting a lot of the other stuff that's going on. I mean, if you have done any CubeSat stuff at U of M, frequently you'll end up in our lab because we'll do the Vibe test for CubeSats too. Does that kind of answer your question?
Yeah, it does. Thank you.
Great.